Hello my dear kids. Today let's jump into the fascinating world of shapes, particularly regular and irregular polygons. But first, you have to guess what's in my hand. A snowflake. Now what's a snowflake? Kids, understand that a snowflake is a heavenly jewel born from the clouds above. Now imagine diving into their world under a microscope. It's pure magic. Just look at each delicate arm, every beautiful pattern, and its symmetrical marvel. They are snow crystals. But look where it comes from. The clouds. And these clouds are wild, untamed, dancing freely in the sky with no set rules. They are absolutely non-symmetrical. You know what is the surprise? They are both made up of same stuff. Water. But you must be wondering why I am talking about snow crystals and clouds and what this has to do with today's topic. So please join me on this captivating journey and you will uncover the enchanting connection between these icy wonders, fluffy clouds and content in this video. By the end, you will be amazed at how seemingly simple elements have woven themselves into the fabric of our evolution. So let's unbox the mysteries together. Kids, understand that in geometric world, polygons mirror the diverse beauty found in nature. Polygons are divided into two categories based on the characteristics. And these characteristics are their side lengths and their interior angles. Based on these characteristics, we divide our polygons. And these polygons are divided into two categories. And they are regular polygons and irregular polygons. Just like our snowflakes and clouds, respectively. Now, let's embark on the fascinating journey through these two parallel worlds. When you see the geometry of snowflakes, you see that it looks so symmetric and regular from all sides. Similarly, if you encounter a regular polygon, you will notice two things. That is, each side length is equal and the measure of each interior angle in a regular polygon is equal. So, to summarize, in a regular polygon, each side is of the same length and each interior angle at the vertices are identical. This uniformity in regular polygons is fascinating. It's like having a polygon where every side and angle at the vertex is a carbon copy of the others. So, let's dive into the mathematical heart of regular polygons, using a regular hexagon as our example. Picture a six-sided shape where all sides and angles are equal. That's our hexagon. Let's calculate the interior angle of this regular hexagon. Remember, in any polygon, the sum of interior angle is given by the formula n-2 times 180 degrees, where n is the number of sides. For our hexagon, n is 6 because it has 6 sides. Plugging this into our formula, we get 6 minus 2 times 180 degrees, which equals 4 times 180 degrees. That gives us a total of 720 degrees. So, that is 720 degrees for all the interior angles combined. Now, here is the interesting part. In regular polygon, like our regular hexagon, each interior angle is equal. This means we divide our total 720 degrees equally among 6 angles. Just like how if we had a total of 5 kg cake for our birthday, we divide it among 8 people equally, each will get a total cake divided by total number of people. That is 5 kg divided by 8 people. Similarly, each interior angle in our regular hexagon is equal to total angle, that is 720 degrees divided by total side, that is 6, which is equal to 120 degrees. That's right, each angle in a regular hexagon measures exactly 120 degrees. Having explored the hexagon, let's broaden our horizon to understand the interior angles of any regular n-sided polygon. Remember our formula for the sum of interior angles? It is n minus 2 times 180 degrees, where n is the number of sides. This formula works for any regular polygon, no matter how many sides it has. So, for any regular polygon of n sides, the total angle is n minus 2 times 180 degree. Since all angles in a regular polygon are equal, we divide total sum of angles by n, the number of sides. So, dividing n minus 2 into 180 degrees by n, we get each angle in a n-sided polygon as n minus 2 into 180 degrees divided by n. So, in a regular polygon with n sides, each interior angle will be n minus 2 into 180 degrees totally divided by n. This formula lets you calculate the measure of each interior angle in a regular polygon. Whether it's a pentagon, whether it's a decagon, or even a polygon with 20 sides, we can apply this formula. Now that we understood how to find each angle of a regular polygon, let's explore the fascinating aspect of regular polygons, their symmetry, just like how we encountered it in our snowflakes. You see, symmetry is all about balance and proportion, and in regular polygon, it's beautifully evident. A regular polygon is symmetrical in more ways than one. First, let's talk about line symmetry. A shape has line symmetry if it can be divided into two identical halves. For example, if you take a square, it can be divided into two equal halves in several number of ways. If you cut along the diagonal line like a sandwich, we get two identical triangles, which are mirror images of each other. You can also cut along the sides like a chocolate, and we get two identical rectangles. Similarly, if we take a basic regular polygon, that is a triangle, we can join its vertex to the midpoint of the opposite side and get a line of symmetry. And we can repeat this process for the other two vertices. And then we will end up with three lines of symmetry. And we already saw for a square there are two diagonal lines which divides them into two equal halves, and two lines that divides them into a chocolate. So we have four lines of symmetry there. Similarly, if we take a pentagon, you will notice that the line of symmetry joins the vertex to the opposite side's midpoint. And you can repeat this process for each of the 5 vertices. And we will end up with 5 lines of symmetry. So, we can see a pattern emerging that the lines of symmetry is equal to the number of sides of the regular polygon. For example, a 3-sided regular polygon, we got 3 lines of symmetry. 4-sided regular polygon, that is a square, we got 4 lines of symmetry. And 5-sided regular polygon, we get 5 lines of symmetry. So what about 6-sided regular polygon? You guessed it right, 6 lines of symmetry. Let's verify that. So let's zoom in on a regular hexagon and discover its lines of symmetry. A regular hexagon has equal sides and equal angles. For this polygon, a line of symmetry is a line that divides the shape into 2 identical parts. In a regular hexagon, there must be 6 such lines of symmetry. 3 of these lines run from one vertex to the opposite vertex, slicing the hexagon into 2 mirrored halves. In our regular hexagon, each of these lines of symmetry are nothing but diagonals. Now, let's find the other 3. You see, if you join the midpoint of the opposite sides of a hexagon, you get 3 more lines of symmetry. And notice how each line creates 2 halves that are perfect reflections of each other. This is the essence of line symmetry. So, we can verify that in a 6-sided regular hexagon, the number of line symmetry is equal to 6. Also, what is fascinating is, as we draw the 6 lines of symmetry in our hexagon, notice something remarkable. These lines don't just split the hexagon into mirrored halves. They also intersect at hexagon's center, which also means that in a regular hexagon, all the diagonals joining opposite vertices intersect at one point. But on the other hand, in the case of regular pentagon or any odd-sided regular polygon, the lines of symmetry are different. They do not involve diagonals joining opposite vertices, since odd-sided polygons do not have directly opposite vertices. Instead, the symmetry lines in a pentagon are the lines joining a vertex to the midpoint of the opposite side. This distinction is crucial when studying geometry. So to summarize, we should realize that in regular polygons, the number of lines of symmetry is equal to the number of sides of the polygon. Very useful and important observation. Now, let's step out of the world of symmetry and enter into the clouds of irregular shapes, or we can just say irregular polygons. Now, irregular polygons are much like our non-symmetric clouds in nature, but they play an essential role in the world of geometry. They bring variety and complexity that enrich our understanding, and also appreciation for the shapes. So, what are irregular polygons? We learned that in regular polygons, two things happen, right? That their side lengths and measure of interior angles are equal. But in irregular polygons, these two things will definitely not happen. That is, all side lengths will not be equal and measure of all interior angles will also not be equal. So basically, these are those shapes with sides of different lengths and angles of varying degrees. While irregular polygons do not have uniform sides or angles, they still obey the fundamental geometric principles, such as the sum of interior angles of an irregular polygon is equal to n-2 into 180 degrees. And also, the sum of exterior angles of an irregular polygon is equal to 360 degrees. Just like how, in spite of looking and feeling different, the snowflakes and clouds are still made up of the same ingredient, water. So my dear kids, these are some great insight into the world of regular and irregular polygons. Now, coming back to how these snowflakes changed our world and human civilization. To understand that, first you must realize these irregular clouds give birth to these regular shaped snowflakes. And these snowflakes, when accumulate on the ground for thousands of years, become what we call a glacier. This happens due to the immense pressure of their own weight. And when this happens on a global scale, we call it ice age. And this very ice age is what triggered our civilization to migrate. To make tools to hunt, to cultivate, to make shelters, to make clothes to escape from the cold, and to learn to live in community. And this pushed us to become the advanced civilization we are today. And also to acquire knowledge and the technology which we see today. And thanks to that, now you can watch my videos online. And that is an interesting thought. So kids, that's the end of today's show. See you in the next video. Bye-bye.